Okay, so in the last video we have seen the loop instruction, right? Loop e is nothing but loop e loop z. So what we will do is this one is also working based on the content of the cx register as well as the zero flag. So if the cx is not equals to the 0, if the cx is not equals to the 0 and and okay, don't think that it is an and operation, it is and zero flag, zero flag equals to the 1. If these two conditions are satisfied, these two flags or these two conditions are satisfied, then the condition is true for the loop e or the loop z instruction. Means whatever the instructions which are there to perform the iteration operation in the 8086, they are working based on the content of the counter register. What about the next instruction? Means for the third instruction, same thing, but same thing, but what will happen is cx, yeah, cx is not equals to the 0 and is not equals to the 0 and 0 flag equals to the 0. Cx is not equals to the 0 and 0 flag equals to the 0. At that time condition is going to be true and it jumps to the label address. So the fourth instruction, jcx instruction, works based on the 0. Means whenever the cx content equals to the 0, whenever the cx content equals to the 0, at that time only condition is going to be true. At that time the condition is going to be true. Okay, so means previously we are looking for the non-zero value for the loop operation. If you want to know the loop operation in one set cx not equals to the 0. So all these three instructions, first three instructions are working based on the cx content non-zero value. But in case of the fourth instruction, it is going to be jumps on 0, that too on which content? cx content on 0. So means whenever the cx content 0, the condition is true for the fourth one. Whenever the cx content is not 0, then only the condition is true in the remaining first three instructions. Means whatever the iteration operations are there, how many times you would like to execute a group of instructions, then that time we are going to take it as a count, and that count value should be there in the, should be stored inside the counter register, should be stored inside the counter register. So this is about the iteration control instructions, iteration control instructions. Okay now? So let us concentrate on the interrupt instructions. Okay, so interrupt instructions are nothing but in order to interrupt the microprocessor at any point of time. Means when the microprocessor is executing some performing some kind of operation, I would like to interrupt that operation, that execution in the middle of the way by setting one of the interrupt. Sima, what exactly the interrupt? If you want the definition for the interrupt, I'll just give the definition. Okay now, so after that we'll see the elaborated expression for the interrupt somewhere, because here the explanation of the instruction set is keep on exceeding. Okay now, so I'm not interested to define. So just take down what exactly the interrupt. So interrupt is nothing but it is a request coming, I think you can't see this one, it is a request coming from internal or external resources to microprocessor. I think you can't see this. Internal resources to microprocessor is called interrupt. It is called as an interrupt. Interrupt is a request coming from the internal or external resources to the microprocessor. Okay, it's called as a interrupt. Okay, so here we are having the two types of interrupts again. One is a software interrupt, another one is a hardware interrupt. During the explanation of the pin diagram of the 8086 microprocessor, we are going to see the elaborated explanation about the interrupt. So just now, for time being, what you do is you just remember that interrupt is nothing but it is a request. Okay, it is a request coming from the internal or external sources. If the request is coming from the internal resource, then it is called as a software interrupt. If the internal request is coming from the external resources, then it is called as a hardware interrupt. Okay now, so whatever the interrupts which are there over here as the three instructions, these are the software interrupts. Okay now, so int type, we have seen one termination of our program in 8086 microprocessor is going to be done with the INT03H na. So means it is a one kind of hardware software interrupt. INT03H, it is a one kind of software interrupt. It is a one kind of software interrupt. Okay na. So here the 03 is indicating the type of the interrupt. Type of the interrupt means here this type is this type is giving the 256 values. They are varying from type value is uh, varying from 0 to, sorry, yeah, type, if you want in the that format. Okay, type is varying from 0 to 255. Total 256 types are there. 256 types of software interrupts are there. For that, we are having the separate memory and all those things. So for every interrupt, obviously we have one work. Okay now. So for every request, we are having one work. Without having work, we don't have any kind of request. Okay now. So that work is going to be written in terms of the program for that particular request. Means for every request there is a program. For every request there is a work na. So in order to do that kind of operation, we are having one program. So that program get executed on every request. Means if I am having the int 03H, in our example we are having the int 03H, na 03H is nothing but it is a breakpoint. Means we are asking the microprocessor to wait for some time. Okay, na, to halt the program. So that is nothing but the int 03H. So 03H type says that stop the execution. So we have like that, we are having the total 256 types. Total 256 types. All these are the software interrupts. And we are having one more interrupt called as a INTO. INTO is nothing but it is the interrupt on overflow. We are having the overflow flag now. OF we have seen. So overflow flag. So that overflow flag, whenever the overflow flag equals to 1, at that time interrupt is going to be generated by using the INT0 instruction. So whatever, as I said, for every interrupt we are having one request now. We are having one request. Interrupt is nothing but it is a request. For every request we are having some work. So that work is written in terms of the program now. That program is called as a ISR. That program is called as a ISR. ISR is nothing but the subroutine or the subprogram which is written for a particular interrupt is called as a ISR. ISR nothing but interrupt service procedure. ISR is nothing but it is the interrupt service procedure. Okay now. So whenever we are writing one program, so let us suppose this is my sub program for the interrupt. Then this sub program should be terminated with one instruction called as a IRET. So means we are returning from the subroutine. So we are having the RET now. In the last class we have seen the RET call instruction. It is a normal return from the normal program, but here IRET says that I am returning from the interrupt service routine, means the request which is there for a particular operation. So from that particular ISR I am returning. In order to mention that I am returning from the subroutine, which is nothing but it is a interrupt service routine. So that program for every ISR is going to be every interrupt service procedure or the every interrupt service routine is going to be terminated with the IRET, means we are returning from the interrupt service routine. We are returning from the interrupt service routine. Okay now. So this is about the what we say, the interrupt instructions. Okay. So how many instructions are there? 3 instructions are there: INT type and INT0. Type is nothing but it is a value varying from 0 to 255. Means in terms of the hexadecimal it is going to be the 00H to FFH. Okay now. So the next one is the INTO, which is the interrupt on overflow. IRET, interrupt returning from the interrupt service routine. Okay. So the next instruction is the process control instruction. Process control instructions means whenever you would like to set a particular flag, we are having the carry flag, we are having the interrupt flag, we are having the direction flag. If you want to set or reset, set is nothing but so here the word is set is nothing but making a particular set. Set is nothing but it is a 1. Making a particular bit is a 1. Reset is nothing but making a particular bit is a reset is nothing but reset is a 0. Reset is nothing but it is a 0. Okay. So here STC is nothing but set the carry flag. STC is nothing but set the carry flag. Okay, we are asking that to set the carry flag. To CLC is nothing but clear the carry flag. Clear the carry flag means set the carry flag means set CF equals to the 1, which means over here I'll take CF becomes 1. Okay, CLC is nothing but CF equals to the 0. CNC is nothing but complement of the CF. Complement of the CF means if at all the previous CF equals to the 0, now the CF equals to 1. If the previous CF equals to 0, 1, now the CF equals to the 0. Okay, it is a complement operation. So the next case is a STI. STI is nothing but set the interrupt flag. We are having the IF flag now. We have seen that one, right? So we are going to have the elaborated explanation in the flag register, but we have seen the what exactly the I. I is nothing but the IF, which is the interrupt flag. So means IF, whenever this instruction got executed, then at that time IF flag equals to the 1, means this instruction sets the IF flag equals to 0 1, and this instruction sets the IF flag equals to the 0. So means processor control instructions are nothing but in order to control certain activities by using the instructions, then we are going with the set clear complement instruction. Set clear complement instruction. Okay, now not only this, we are having two more instructions also, which are nothing but the STD. STD is nothing but set the direction flag, and CLD, which is nothing but clear the direction flag. Clear the direction flag, which is nothing but the DF. Okay, now so in short, this is a processor control instructions are nothing but to as the statement says that these instructions set or reset the sum of the flag bits like a carry, direction, and interrupt flags in flag register. Okay, now so in order to control certain activities of a particular operation, we are simply going with the processor control instructions. Okay, now with this the instruction set of the 8086 microprocessor is over. So let us review one time. So instruction set of the 80, what is the instruction? Means you may get the question like this: define the instruction and explain the instruction set of the 8086 microprocessor. Then obviously you are supposed to define the instruction. Instruction is nothing but it is a binary information given to the microprocessor to perform a particular operation. Okay, now to perform a particular operation. Depending on the type of the operations, the instruction set of the 8086 microprocessor is divided into these 8 types. Okay, now so we have seen the data transfer instruction, arithmetic instruction, bit manipulation instructions, string instructions, branch control instructions, iteration control instructions, interrupt instructions, and process control instructions. You are supposed to explain each and every block with one or two examples. No need to write. Means list out all the instructions which comes under the each part, each set, which is a data transfer instruction. Means you write the move instruction, XCG, XLT, push, pop, all those things, and explain one or two instructions under each category. So don't try to explain all the instructions because you are not going to get the sufficient time in the exam. Okay, so this is all about the instruction set of the 8086 microprocessor. If you are having any queries regarding this one, you can ask me in the WhatsApp group. Okay,